Welcome to the AgilEntity tutorial that will describe briefly how the AgilEntity framework allows nodes to distribute resource requests between one another in a very intelligent manner. I'm going to log in using the superuser account, and this account immediately takes us to the configuration page where we can see immediately what the particular distributed capabilities are on the system. At the very top, we see designation of the branch that the particular node to which we have been authenticated is a member of. It's branch 1, of which there are 20 possible nodes total for this branch. This is an arbitrary value indicated when the branches are created, and branches themselves are managed objects, managed entity types. And users with the appropriate settings can modify how branches are, what the attributes of branches are. Then there's a name for the branch and a description. Now, under the branches are the number of nodes that are active members of that particular branch. Currently, there are 2 nodes, one called Scorpius and one called Aries, with the indicated IP addresses, node IDs, DNS host names, activity states, and descriptions, which specify particular hardware specific or location specific characteristics of those nodes that are important for purposes of ensuring that they are efficiently handling resources based on the particular memory and disk resources that are available on those machines. And speaking of memory and disk resources, we can see that there is a bar that describes how it is that memory is currently being utilized by the JVM. This indicates to us at a glance how the current node is performing with creating new objects, using those objects, and then relinquishing the use of those the memory components for those objects back to the system. And this allows us to monitor in close detail what the particular memory use characteristics are of a node. And we can specify particular parameters, as indicated further down on the page, which allow us to send off notifications, warnings, and to perform automated actions such as automatically taking in more memory, or instead routing incoming requests that would force memory to exceed a certain amount to have those requests routed to another member in the AgilEntity cluster, whether it be a node in the existing branch or nodes in another branch, should the entire branch siblings, the node siblings in a given branch, be saturated. So what we'll see here is a description of the amount of memory that's used. Current memory, 7 megabytes. Allocated memory, maximum memory, free memory of the amount of RAM allocated to the JVM, and then the memory saturation percentage. And below this meter is another meter which describes an even more interesting attribute of running a web system, and that is how the connection pool on this particular node, each node has its own connection pool running, how the connection pool is doing with leasing connections, granting those connections to application object instantiations or utilizations as they are performed by users on the system, and then relinquishing those connections back to the pool. And this activity can be monitored as well as resource utilization spikes. There is the ability to specify specific memory values for the pool. So as you can see here, we can set minimum allocated connections, we can set the max used connections, we can set a percentage of saturation where a warning is sent out to administrative users, um, configured to to notify the connections pool log, which is written when such events are occur. Beyond the warning, resource requests are redirected at 90% saturation, and the actual pool itself is reset at 99%. Now, since the redirection percentage in this case is less than the reset percentage, this will never occur, as resource requests that exceed 90% will be redirected to another node. Now, this button indicates whether or not the behavior upon saturation will be to bloat or not to bloat, in which case, rather than reset the pool, a bloating pool will simply use an algorithm to calculate an additional amount of connection objects to create, allocate the amount of memory required for those objects, create those objects, and then continue to hand out those objects to the system. So if the limit on the amount of RAM available to the system exceeds the current use, bloating can be used to allow a system to accommodate additional resource requests as far as connections are concerned that exceed the specified saturation percentage without having any of the DB connections dropped or interrupted in any way. And then there's a description of the actual values and the bloat state as well. And so, and we have the ability to reset these values to default values specified when a new node is installed on the system. So it is a very powerful system for managing how a set of nodes can route requests from and to one another based on their own individual detailed settings for memory utilization in the JVM and DB connection pools utilization. Based on the hardware that is available for each of the machines, different settings can be set for different nodes. In this particular case, we're on node 2. We can authenticate into node 1 and perform the same management capabilities on that node. The changes performed in this section of the configuration interface are unique to the specific node that we have been authenticated into. And we can specify different nodes by clicking on the hyperlink under the nodes specified here. So if there were multiple branches, there would be additional items here, and we would be able to then select between the branches to select different nodes that we can then authenticate into. So our ability to manage each node, whether they're geographically dispersed or not, from a single location is given to us, and this is a powerful capability for managing the entire cluster. Now, each node has its own permissions because node itself is an attribute, an entity type. So because nodes have permissions, different users can be given access to different nodes or different collections of nodes, or just entire branches, or subs, or multiple branches. So our ability to delegate responsibility across not just entities that govern the actual applications that are running on the system, but the actual system itself is provided by the AgilEntity paradigm of permissions applied to entity objects and managed through a common interface. So that finishes the tutorial, which describes the distributed application and resource handling capabilities of the AgilEntity framework. I hope you enjoyed the tutorial. Thank you.